This is your second and last video in 6.5. We're going to be talking about rational exponent equations in this particular video. You notice that rational exponents that we talked about are fractions that are exponents. So we have a fraction here. I want to solve this equation. Basically, I want to find the value of v such that if I multiplied and then took this power, I get 1,000. Okay, so we have to figure this out, and I'll show you some strategies and some tips on how to do so. Let's get it started in here. First thing we have to do, just like we did in the last video with square root equations and you know, higher power equations with radicals, you have to isolate for the exponent part, right? So exponent, whatever that looks like. It could look like this. It could be a binomial with that as an exponent. But we have to isolate for that. Basically, it means that if I have a number that's like 3 plus this, then I got to bring this over. If there's a number in front that's 4 times it, then I got to divide and bring that over. So we have to just get rid of everything that's not contained with the exponent. Okay? So that's the first step. The second step, just like we did in the last video, we raised it to the index. What we're going to do is raise both sides to the reciprocal of the exponent. Now, what is reciprocal? Remember, reciprocal just means the fraction is flipped. So if it's a over b, then the reciprocal is b over a. So this one's 3 halves. Okay, so I'm going to take both sides and I'm going to flip it, and I'm going to do the math. When I do this, remember, I can multiply exponents from the previous section. 2/3 times 3 halves goes away, that becomes a 1. So it's just 100v equals. And then remember from the last section, we said 1,000 caret parentheses 2 divide by 3 parentheses enter will give me another value. Okay, will give me something else. But then we said since the numerator is smaller, right, it should be a smaller number. So this would be 100. When you do this on a calculator, you should get 100. Now I'm dividing, v equals 1. Okay? V is equal to 1. And you don't even have to really check. So 3 is then solve, and then 4 is check, but you don't necessarily have to check on these. There shouldn't be any extraneous solutions on these types of problems. You can check, you can very well do that, and you'll get the right answer if you plug it back in and solve. But you don't really have to do this here. Okay, let's go on to some more problems here. All right, here we go. Let's move on. This one's going to be a little more complicated. There's one more step we have to follow here and go from there. So again, the first one is isolate. Is everything on the left side contained within the rational exponent? Yes, it is. This is all inside with that. The second one is to raise to reciprocal. I'm going to raise it to the 3/4. 3/4. Now, here is where it gets a little tricky. We need to really follow along and make sure we understand this, because there'll be more problems as well when we get there. So, what happens? When I flip this, this technically goes away and I get 3x minus 34 equals. When you do this on a calculator, okay, you're going to get 8. So that's all well and good, we get 8. But here's where the caveat, with the caveat. Caveat. That's how you spell it, I know, right? So with the caveat. Caveat means there's some added thing that we have to account for. When. So this is like a big time rule here. When you introduce an even root. So what does that mean? Well, when I flip this, okay, when I flip this, I introduced an even root. This is now an even root. Remember, my denominator is actually the root of my equation. So it's really the 16 to the 3rd power with the 4th root here. So I introduced an even root. In the original problem, I had an odd root. I introduced an even one. When you introduce an even root, you get a negative and positive value. So what does that mean? That means that I get to 3x minus 34 equals 8, and 3x minus 34 equals a negative 8. So both of these are considered answers. Okay, one is positive, one is negative. This you need to understand, all of that. When you introduce an even root, you get a negative and a positive. So instead of just getting one answer, we're going to get two. Okay, we'll get 2. So now I do the same math. Plus 34 and divide. 3x equals, and this is 42, x equals 14. So that's one answer. What's the other one? Add 34, 3x equals 26, it looks like, and then x equals 26 over 3. It is okay to get fractions. It is okay. So my answer, x equals 26 over 3, comma 14, and that's it. If you want to put these in brackets, curly ones, you can. That's okay as well. Okay, let's go on to some more problems. Let's do this one here. Again, first, isolate. So this is the exponent, this is not, so I got to move the 3 over. So I get 16 equals x to the 2/3. I got to raise both sides to the reciprocal of the exponent. So what do I get here? I get x equals 16 to the 3/2 is going to be 64. Okay, 64. But remember from the last video we had that caveat, okay, which was added. I introduced an even exponent right here, or an even root, right? Even root. So I get x equals the 64 and the negative 64. Okay? Now, can I solve any more from there? Nope, I am done. Those are my two answers. X equals negative 64 and 64. If you want to write it that way, you can. If not, just that's not a big deal. But you get two answers. Even root when introduced. You get two answers, positive and negative. Okay? When you introduce an even root. You'll have some more examples as well, but that's the last one I'm going to talk about, so we need to understand that. Let's go to this one here. Again, I want to isolate, so I got to bring the 5 over, so that gives me a 512 equals x to the 3/2. Raise it to the reciprocal, 2/3, x equals, and then 512 to the 2/3. That's 64. And you notice I don't have a negative 64, it's just a positive, because my denominator is odd. It's not even, it's odd, so I don't need two answers, I only need one. Boom goes the dynamite. That is it for that one. Okay, let's look at number 8 here. This will be the last question that we do in this video. So I want to isolate. And how do I isolate first? I need to minus this and minus this. So I get negative 3k to the 5/4 equals negative 96. Is this isolated for the value of the exponent? No, because the k has only the exponent, so I have to divide by a negative 90 or negative 3 there. So k to the 5/4 equals negative 96 divided by 3 is positive, 32. Now what I want to do is, again, flip it reciprocal, so 4/5. Raise both sides to the 4/5. You notice my denominator is odd. That means I don't have two answers, I only have one. These cancel, k. 32 to the 4/5 is going to be 16. You can do that on your calculator. 32, caret, open parentheses, 4 divided by 5, close, equals 16. Answer, bingo, bango, bongo. Okay, that concludes this particular video. This is the last video in this section, 6.5. Past this one, you are ready for your test. Alright, you need to make sure you are good to go. But other than that, should be good. Okay, take notes, do work, be successful.